Hello. So I did a bad, and I went and did things during the week, and I'm gonna turn this down a little bit because it's kind of like, there we go. Yeah, so I did a bad. I did some things during the week that I don't even have a gate on. Oh, sorry. During the week, so that because it just hit me that I should be doing these things. Minus 26. Minus 26? Okay. I did. Okay. Um, so what I ended up doing was getting our thing working from last week. So what I'm going to do is I'm going to show you what I did. So remember we had that code from the Unreal Discord about how to find actors with particular gameplay tag. And it was like it had some other weird stuff in it, and it wasn't clear where to put it. So what I ended up doing is I did a little bit of refactoring, and I put it in here with the HUD stuff. Remember we had the find screen edge location for world location function for doing the HUD. So since it has to do with that, I figured this is a good place to put it, though I don't think it's the best place. I'll figure it out later. One thing is that's weird. There's one that's for finding a single gameplay tag and one for multiple gameplay tags. I actually never got this one here to work. So I can only go for one gameplay tag, but that's all we're doing. So that's all we're gonna do. So the other one had like, oh, that's the one. So the one that we found on Discord had a whole thing about finding whether it was an actor that implemented an interface about tags that wasn't gameplay tags, but possibly the normal tags, but not. I don't know what it was about. I think it was his custom stuff. So what I did is I just took it out. So where he has this thing where it was like, oh, run your actor through this function to determine what kind of thing it was. I just said get the ability system component done. So that's the one that works. I wish I knew what the difference was between that and this. If not ASC continue. Maybe I should just make this. No, maybe I can refactor it while I'm here. Give me a second, because we should be. If not ASC, don't do anything. I feel like he's got it backwards, eh? If ASC. Then do these things. Right? Am I right? I think I'm right. I'm pretty sure I'm right. We'll see if that helps. I don't think it will. I don't think it will. Because I need to return something at the end of this. I don't have out actors. Maybe it has a different. Sorry. I just gotta know. I gotta know. Yeah. Sure. All right. Anyway, I don't know what's wrong with this one, but this one here works with the single tag. And so just to kind of like run over it, once I cleared out all the other stuff, it became pretty clear what it was doing. You get all the actors in the world context, and if they have a ability system component at all, see if it matches a tag, add it into out actors. It seems like a big deal, but kind of it's fine. It's fine. People do this stuff all the time. So, this has been edited. Did I edit it? What is edited? We'll never know. So, let's take a look at what this looks like in here. So that it becomes really simple. You have find all actors of gameplay tag, you put the tag in here, and you get all the actors. The next thing I had to do was filter it by guests. I'm kind of thinking of redoing it this where I only get like characters so that or pawns even, because otherwise you get everything. But on a certain level I kind of don't want to do that because we might be able to use this for something else, not today but another day. And so refactoring something to add something that I'm going to take out later seems like too much work. So yeah, so then we end up with the same kind of thing that we had before with the widgets, only we've got our actors for each loop. Update threat indicator widget. So yeah, we're adding new threats or removing non-threats. Since we have this array of actors with the threatening tag, we know at this moment what are the threats and which we should add and remove. Oh, I almost forgot this little bit here. And you know what? I'm going to make sure I don't forget it again. Because I forgot it the first time, so I'll have to. This is probably a good idea. So here we're removing ourselves. Otherwise, you get like a little threat indicator right at the bottom that doesn't move because it's constantly pointing to yourself. So that's us doing that. So we get all the threatening actors, remove anything that isn't a character. Which actually, you know, I'm gonna see if does pawn do it. I'm going to put in pawn. I don't need to. Which is guest characters, because there's another object. I suspect it's like the player controller gets spawned somewhere, and it just stays where it spawns and it never moves. So you always get two indicators, two things that are threatening. You get two things that are threatening in the game world per player. You only want to see the ones that's attached to the pawn, which is the guest character. And then we want to remove ourselves because we already know that we're threatening. We're the threat. And then this becomes the thing that goes into here. So we add and remove threat widgets. So that's what these are. I should probably rename that at some point, but that's what they do. And then we go through and update the widgets. And I don't know if I had this this refactor. All I did was take everything out of there and shovel it into a macro, so you don't actually have to see it all the time. We just know that we're refactoring, we're updating those threat indicators. And then if we host a game, there you go. And guy joins. So you can see that this guy is slightly off to the side. Move out of the way. Hidden back here. So we push this button. All right. Remember, I have this button here that's become threatening, and you can see it move around the edge of the other player's screen. I, being the person who is threatening, does not have it. And Now I am being threatening in the view of the person, and back around here, and the indicator returns. So that was what we were trying to do for the last 2 weeks, and we done it. Yeah. So, done. We look at our little thing here. So this is done. I'm going to call this done. These effects I'm going to leave for a little bit because I want to look at the clues system. So I had this whole thing about the clues, and they should be linked. Is it some sort of graph? It's going to be a master clues graph, and then we compare what you think you have, and then I decided that was dumb. But it does create an easier clues system. So we've got this thing where I was trying to figure out, like, you know, what kind of clues we have, what kind of edges we have. I'm gonna get rid of the kinds of edges. I will right now. Done. And then the nodes are like this. There's lots of nodes, but one thing that you may notice is that most of these, except for like player or maybe location, are those clue gameplay tags that we're using to tag a clue. So most of these just boils down to like a clue being a gameplay tag and maybe an actor and a relation and a list of relations. And that makes this entire kind of graph work a little bit better than what we had before. So let me go there. I haven't done much implementation. I've done a bunch of declarations so that you don't have to watch me suffer through doing a whole bunch of declarations. So we have our old evidence, which we have different kinds. We have the tag, which is the kind of clue, the actual fact, the location. We have an acting player, victim player, unique clue ID, drops, etc. And I've simplified that down. So we're down to a tag. All right. So instead of having a kind and a fact, I'm just gonna have the tag, and when you see it in the thing, it'll say red hair, but like you don't actually care that you've gotten a hair. You care, right? You care that you've gotten the entire fact, which is a red hair. So I'm just keeping the tag. We've got a thing, so if it is like a player or a location, we just dump this in here, and it's an actor. I assume for a location, what I'm gonna do is I'm gonna make some sort of like, kind of like how the clue is this thing that has like a radius. It'll be like a scene, a crime scene. It'll have a radius, and anything happening in there will be associated with that. We've got this thing which is unique, which is equivalent to, why didn't I double click on it? Equivalent, I didn't double click on that one. It's equivalent to our drops. So you have one thing, you're gonna drop it or not. I don't think we're gonna have somebody have 17 gold watches that they block, that they can drop, but no more, right? Either you dropped your watch or not. Finally, there's this one which is common. It says common knowledge should not show up in the detective UI. I'm going to show you how. I'm going to draw out the graph so you know why we need the common knowledge. So you shouldn't, when you're trying to bring up the UI to figure out who did what, it's not something that you should always see. Finally, we have an array of links, and it's an int. It's an int. And you're saying, what? Shouldn't it be a clue? It's like, no, give me a second. So after that, there's a class. So the clues, I figured the best way to do the clues would be as like a kind of entity component model type thing, where I have this thing called clues, and you just refer to things in the clues collection, but you don't really actually like mess with the clues themselves until they get spit out by the clues. I'm missing something here, aren't I? We'll cover that in a minute. So I declared an add, so you can add, create a clue, add it. You can find a clue, and the tag and the thing of a clue are kind of like your unique ID. So like you can say, I found a red hair. Red hair has nothing to do with a particular thing at that moment, so it would just be red hair, and the thing would be null, and you know that's good. Or this is a person, and the person is Bob, so your unique ID for that is person Bob, because the person won't have any like ability to be a gameplay tag. We can't add those in the middle of it, so we have to do that. And then we have this thing called walk to, and I'll explain that in a little bit. While you're here, you'll have to suffer through at least one declaration, which is, of course, f clue. Because the clues are private, right? There's your super complex get function. All right, so we're going to go and copy that, hop into clues.cpp, paste it. Oh, that's the wrong button. I think you can do that. It's a struct. I don't think you can do that. We'll find out. We'll find out when it complains. All right. So there's no implementations here yet. This one's gonna be easy-ish. This one's the easiest, I think, but it's expensive-ish. So the idea is that you are only storing the index in the clues array of the clue you want to deal with, and you'll get it later. So we shouldn't have to do this unique ID searching thing every time. It also means that as an array, you can replicate it. You can't replicate a map. But an array has this convenient thing that is a map of an integer to like a row, so that works out. Finally, we have our walk to. We've got a start, we've got tag, we've got nose, and we've got touched. What this is it's going to allow us to walk the graph to find out to kind of get an idea of what the clues we have gives us as a detective. Because the clues, what you know as a detective, is different than the clues. So we have implemented our master clues graph. That's the clues class. So everything that we know about the world exists in this clues class inside this clues array here. And what you know is going to be a separate list of things And you'll be able to, if we do a walkthrough, we'll be able to ask in the UI, for example, I have a red hair. What people does this link to? Because everybody who has red hair will have a link to the red hair, will be included in the graph as a player with the player tag, and then have a link between that player and the clue, which is red hair. And if I say I have this clue, which is red hair, and then I will be able to walk to a tag, which would be player, and then if I know it, and then the touched array is a list of things I already looked at, so I don't end up going around and around in circles infinitely. I promise to draw with my mouse. That's gonna suck. Can I make it smaller? Smaller? Not that small. All right, we'll do this one, and we'll just 51. What am I? All right. So essentially, what we want to do is we want to have a graph. So I'm gonna make a person. Whoa, I'm not good at drawing with my mouse. He's gonna be called Bob. I'm gonna put a circle around him, and that's anything that's in a circle is common knowledge. So for example, I'm also gonna put hair. Sure, and it's gonna be blonde. To put red because it's less letters for me to try and draw like this. Why don't I use the text tool? I don't know. It's a circle, and there's nothing there. I'm not saying who has that blonde hair. It's just a thing that exists in this world that we know exists in this world. It's common knowledge. Hair can be blonde. And now I'm going to use a text tool. And then hair can also be red. And we are going to put a circle around that because it's common knowledge. Oh, I've screwed it up. Is that what I had before? That's what I had before. Oh, wait. There we go. So we know that Bob has blonde hair. We know that. That's common knowledge. If we find something at crime scene, we're gonna make something called a dropped, and then probably that. Remember how I said there'd be like some sort of clue crime scene object. So I'm going to call that drop here, but it might be called something else eventually. I'm going to put it in a square. You have to find this and add it to your knowledge graph. And what it's going to go, and it's going to go like this. So this crime scene, this thing has been dropped in this crime scene, and it is, actually you don't even need this part, do you? Because it'll have a unique index in our master graph, won't it? And the index is good enough of an ID. So screw it. Oh, that's the opposite. Move everything else. There we go. So it's just a drop. We're going to call it a drop. If I find that drop, then I know this one. And I can walk. I can say, walk me to players. And I can follow this link to here. And I can follow this link to Bob. Let's say there is also a blue. Bob is wearing cloth exists and is blue. And Bob is wearing that blue. And he's dropped some blue somewhere. I don't have a link to this, so I can't walk from here to blue to Bob because I don't have this as a starting point in my knowledge. I know that blue cloth exists. I know Bob is wearing blue, but because I don't have that starting point to walk to here, I can't get to there. I can't get to Bob from there if I say walk to a person. The other thing that might happen is you might have something else, which is a weapon, and this might be something like poison. And again, we know this exists. It's common knowledge that people can die. People can be poisoned. We're detectives. We know that's a thing. And then we might have another drop. We can have blonde hair dropped. I'm just going to use squares for this because whatever. A blonde hair dropped. And wait. I remember I had like the whole like scene. We'll have our scene. And this gets created when we do something that creates a scene. Though I have a feeling I'm just gonna make it location. We'll see. I haven't figured that part out yet. So that this drop is part of that scene, and then this weapon. Somebody poisoned somebody. That the fact that happened is like that, and this goes from here, and that goes from there. And this is in the scene, and I over here, yeah, I know there's a lot of squares. Just follow me. Know that there's poison weapon. There's a weapon poison at this scene. Wait, sorry. So this is the one I'm looking for, this drop. So I'm at the scene, and I have poison and weapon. I also find the blonde hair at this scene. So I got this one, and I have this one. I can say, well, this points at Bob. This weapon through this scene also points at Bob because this weapon was found at the same scene as this hair, which points at Bob. So even though technically, yeah, the hair points at Bob, but we can trace from the poison weapon, like the evidence of this poison, that it could also be Bob because they were found next to each other. We can make that relationship and say, okay, this has to do with that. And then so when you go into like your detective UI, you say, all right, what are my clues? You say, well, what are the clues about the weapon? Well, the weapon was found in the same spot as this blonde hair, which could implicate Bob or Alice. Because she also has blonde hair. And we know that. That's a common thing. But that's a lot more clues that you got than just having, oh yes, I have poison. I know poison did it. How does that help me? So you'll be able to get this information out of what you pick up. And storing it all will be easier. C++, there we go. So let's go ahead and actually one more thing I want to show you is a guest player state. So essentially, we've got our evidence here, right? That's how our evidence and clues work currently, which is collected evidence, collect evidence, evidence I can drop, collected evidence, and collect evidence. Oh yeah, that's because I'm supposed to rename these. So I'm kind of like adding on the clue stuff onto it. I've got clues I can drop, but it's just an int. We don't have to have like actual copies of those clues. We're going to have a get clue to drop, which is going to be the same as get evidence to drop. We're going to have, I don't know why this is like down here when it should be like up there. So this will be, instead of an f evidence, it's going to be a f clue. Oh. And we're actually going to rename this to knowledge. So this is your knowledge. So things you know. And then down here, we'll just call this let's say collect clue, because we don't want it like to be int. Don't want to be too confusing with it. So this will take over from the evidence. So you see it's a little bit, stuff that's getting replicated back and forth is a little bit easier because you're just saying, oh, it's an int. We all know which one it is. Actually, this is also wrong. This will just all be an int, right? Because if you do need to look it up, you'll go look it up in the clues global object, because that's all you really need. Let's do. So let's start with add. Oh, so I'm going to go back to here. I have no arrows on here, so it goes both ways. I can say, tell me all the things about Bob, and I'll say, oh, blonde, wearing blue. If I've collected this, it's in my realm of evidence, I can say, well, it's possible that this thing collected here belongs to Bob. So we can do that both ways, and we'll need both ways in order, because there's some things that like kind of do work both ways. So they're going to have, our links are going to be two-way links. So when we add a new one down here, we're going to say, we're going to add to the clues our clue. But also we need to create some links. So and it's going to be -1, right? So we know how many there are in the whole set. So the last one must be the last 0 index, C++. So it's going to be the last one -1. So number of items -1 is going to be the index of the one that we just added. Then the new one that we just added should have its own list of links. If we go back to here, we do have an array of links. So we should be able to go and say, 4, and then I have to relearn this one. It's the big L, first of all. Give me a second. I just gotta double check if that's the right. Okay, that's great. Show it to me. No, this guy's asking about it. Show it to me. Iterating through the vector, int iv. Yeah, all right. That's exactly what I want. So I should be able to do for int iv. So for each thing in there, I will go get it. So, so for auto, right? It was I. Let's make sure it's I. Int. So output 1, 2, 3, 4, 5. Right. So it's going to go into links, and then it's going to go into each thing in the array, and it'll put it into I. So I don't have to go I. Well, you'll see in a second. So essentially, this I is going to be the value. I'm going to call that V, so you know, we'll both know. The value that you get from links is what you get out of that for loop, not the index. So for each one of those, I'm going to go into clues, right? Because our unique ID for every clue is just an index in the clues array. All right, so for every one of the links that is in this clue, we're going to go to that clue, get it. Yeah, every one of the links in this clue, we're going to take that clue, get it, go into its links, and add this clue's index into that. So every clue has a backlink back to itself. So if I have my picture, well, that's not my picture. So in my picture, if I add this drop, and this drop has a link going this way. When I do that, I automatically go onto this one and make another link going back that way. You can go both ways. The reason you might say, well, I don't want to do that because I just want to drop and then go hair and then bob. Well, that means that the hair has to have bobs, not Bob has hair. If that makes any sense, because if you only go this way, but Bob might have hair, you usually say Bob has a link to those hair, but you wouldn't have hair has links to the Bob. You can go the other way. And then you got this poison weapon. If this goes this way, and we'll do this, and only this way, and this only goes this way, you can see I can't go from the weapon through to the scene, through to the blonde, back to Bob. So having those backlinks allows us to go anywhere in the graph. The find I'm going to leave for a little bit because I want to talk about the walk. So we're going to initialize the walk array found. All right. First thing we're going to do is remember again our unique ID for a particular clue is its index in the array, except when you're trying to do a find and you can't exactly, like, you don't know, essentially you don't know the index in the array and you're trying to find one. So if clues.start if it's common, oops, that's the wrong button, or, oops, oh, what button did I put? What button did I do it? Or clues, oops, oh, no, knows think in if it's common or is contained in our knowledge, right? So if it's common or is contained in our knowledge, actually, the first thing we should do, by the way, everyone, the first thing you should do is if clues, if you're clever, you would have figured this out by now. I didn't, that's why I had to go back. Oh, I'm taking it back. What if I have a player and I want to link it to another player? All right, we'll think about that later. If I don't have like a proper end condition to this later, then I might have to put that in. All right, so if it's common and we know it, we can deal with it. If it's not common, so if it's not common, all right, and we don't know it, there's no way we can deal with it. So again, in our picture, if I don't know about this scene at all, right? So I'm here, I start here, I go, okay, drop. I know the hair is blonde. I go down this way. I don't know this. I shouldn't be able to link that blonde hair to poison, right? Because I don't know this one yet. So it should stop. I can go through any of the common ones, but if I don't know it, our walk stops and doesn't let me through to the other side. So if it's a common one, we can look at it. If I know it, we can look at it. If it's not one of those, we don't get to look at it. So if we do get to look at it, first of all, knows, all right, let's see if we know it's a person. I'm trying to link it to another person. We should know this one. So we don't need to start here. So we'll go right into it. We're going to say, we're going to return this dot walk to. Sorry. this is where we're going to do another for loop. So for every value in clues start dot links. So for every link, we're going to do this. And we're going to go found append, and that's going to be this dot walk to. And instead of start, it's going to be v. The tag is still going to be the tag, and we're not changing that. Knows, we're not changing what we know. And touched, we're not changing that here anyway. That's another end condition up there. If just return found it right away. We've hit in it. We've hit something we've already looked at. Just we're done looking at things. We go here, found the append these. So everything in the links we do, return found. And up here, yeah, if we do it this way, we have to do. Well, actually, no. We don't have to do that. We can do it down here. Let's do it here. If we have to do it somewhere, don't we? Let's do it in here. All right. So before we go walking down the path, we're going to say if the link meets our criteria. So if clues v, because it's not the start, it's v dot tag. Oh. And what we're going to do is we're going to go found we're going to add it. And then we're going to return. Right then and there, we're done. Actually, no, that's not right. That's not right. Sorry. No, yeah, it is right. No, it's not right. We're going to add it to the found. And then we'll put this in an else. So what we're doing here, because I've been so scatterbrained about it. So first of all, if we've already messed with this node, don't do anything with it. Return what we have already, which is nothing. It's going to be a blank. Then if it's common knowledge and we know about it, or we know about it, then we can deal with the children. For each of those children, we're going to see if it's the one has a tag that we're looking for, and if it does, we'll add it to our found list. And then we're going to stop. We stop. If it's not the one we're looking for, then we're going to go into the links to this one. And append it to our found. Once we've done that, we'll be done. Return found. So this is going to recursively walk through the tree. I think it's going depth first, right? Because we've got an append here, so it's not coming back. So so if we do a walk from here for people, then it's going to go here from drop to blonde, and it's going to say, all right, this is where we start. So I'm going to check all of these. Oh, I only have one, because that's generally how it's going to work, is that the drop is going to give me one know about this. And then on the hair, we're going to go, okay, well, I'm going to go start here. Alice. Okay, add that to the list. Alice. That's not the button I wanted. Right, I'm going to make this 0. I'm going to make this 1, because we're going to add all the people first. So I'm going up here. It matches the tag. I put that on my list. All right, next. Go here. Matches the tag. I'm going to put that on my list. All right. Here, I don't know about this, so I'm not going to go. But if pretending we do know about this, I can go to here. I can go, probably got that from that, so we know about that one. We might not know about that one, and we end here. And when we come all the way back, we have a blank, an empty found, because nothing got added. None of these guys are people. Let's, for example, do something like this. And if you're picking up what I'm putting down. Let's see, at this scene, we also got a red hair. That shouldn't flow through, should it? Having red hair doesn't link you to Chris. But I would have to know about the drop, wouldn't I? So there's a drop in here. Even if I found a red hair there, I shouldn't, right? I found a blonde hair. I know about it at this scene. There's also red hair that I know about at this scene. That doesn't lead it to, that doesn't lead a blonde hair to be associated with Chris. So this doesn't quite work, does it? Maybe I do need directional ones. Take a look. Let's take a look, everyone. Found a drop. If we make these all point this way, that can get us to the scene. That won't link us to the weapon of poison. Maybe that's where you have to make your logical detective leap, right? Because otherwise you get down to Chris, who probably just dropped their hair there doing something else. Or could have done it, I don't know. But it shouldn't you shouldn't get to this from a blonde hair drop. So I think they have to be directional, eh? But that's easy to fix, right? We just don't do the backlink. That's all I was trying to do. I don't know why it was so difficult. All right, so let's not do the backlink, and that should work as long as we make that graph proper and we'll be able to walk it properly. So this algorithm of walking works. It's just a matter of whether we put backlinks or not. This is way easier, if I remember what buttons do. This is just I better make sure that matches over here. I'm dumb enough to have put that there. Oh my god, that. Then we have the find. This is the most expensive one. The only reason we have this in here, why do we have this in here, is if we need to create a new one. So I'm creating this drop. And it's based on, no, we don't need to create this drop, do we? Because we dropped it from a person, and the person knows what it is. Why do we need this? And the answer is, there is an answer. I don't know if we need to do the actor. I just gotta think about it. Because essentially the only reason to have this, I'm gonna write it down so we all remember what it is. The reason to have this is for initial setup. Right? So you're starting the game, you're saying, okay, I have all the common knowledge. So whenever we start a match, well, let me hop over here. Whenever we start a match, I don't even know where that thing is. Do you know where that thing is? I think it's in here. I might be wrong, but I think it's in there. No, not in there. Somewhere in this thing is a list of my gameplay tags. I don't know where it is. I know how to get there though. I just need to go into this. It's in here, I swear. This guy has one. Oh, you know who definitely has one? So we've got this, and we have the list of tags. I don't know what there must be somewhere else in here to do that. All right, so when we set up a new match, everything in here, so all these things, so all these facts, so clues, hair, etc., are going to be added to the master graph, whether they're actually in the game or not, right? So you don't have to you just generate everything and dump it into the graph. I have half a mind to take all these, put them into C++, and default the graph, the array to these, and almost. Ooh, if you had them like a const or an enum, you could totally like. Anyways, the point is, these all will be there, right? Everything in here will already be there, and then when you actually add a player to it and create that link, you need to go into here You say, okay, this player has black hair. You need to go into black, move it, and add the link from black hair to your player so you can follow along to get to the player. But if I put all these in C++, I won't have to do that, I don't think. Do I need one for a location? I don't think, right? Because if you create a scene and you do a bunch of stuff there, if we make the scene an actual location, then it's kind of like, oh, okay. So yeah, there's a whole lot of like, I don't actually like need to do this, I think. The other thing I can think of, the other situation would be if I have an item, like an actor item, right? So I have an actor item in the world and I've left something on it. So let's say there's food. I've added, this exists in the world, a food item, a unique ID. So it has an actor, much like the Bob and Alice and Chris have an actor associated with it. This food should have an actor associated with it. And then we add this into the world. It would be common because we know that food exists in this world, and if we just sitting on the floor, we know it exists. And then we say that we add to the world that there is a hair on it. And so on the food is a hair on it. Now, before, and you can see it in this chart, I had like a kind, so something that's been dropped or attached, and the facts. I think I'm going to get rid of these because it'll be like clues, hair, clothes, etc. And then there'll be clues and then kind. And you don't have to have, you won't have a kind of hair. You won't have a thing that's, oh, this clue is a clue of kind hair and the hair is black in one, a clue of kind dropped and it's black hair. It won't be in one node. It will be in two separate nodes. So this is going to be, I could probably drop, we'll see. But that makes this simple. So you can go food to here, and using this, you can go to here. Food is attached to here. All right. And then we'll have another one called K. And this poison killed Alice. This food is attached to the poison. This see, now you get a thing that's like, oh, there's poison on this food, or the food is poisoned. Poison, no, it doesn't matter. We found poison on this food next to blah, blah, blah. I don't think it matters. I don't think it matters. So this, I'm not even sure I need this. I might not implement. How about we don't implement it, and the moment I need it, I'll implement it. All right, so I have one more thing I need to do. Guest player state. I take all these. I think if I'm smart, I've done it already. If I'm not smart, I haven't done it already. I am, as we all know, I am not smart, so I haven't done it already, which is to put these in here so I can, say it's done. have it actually compile, which is a goal of mine. It's not like a big goal, but it is a goal of mine that this compiles at some point by the end of the night. It doesn't have to do anything, it just has to compile. So we get this public, get our clues to drop. We should have something. Do we have something like that? Do we have something like that? Oh, of course. That's not even a. It's not. I'm a dum dum because this isn't. These two are not functions. I don't need to implement a variable. So this is going to do the same as get evidence to drop. So only instead of like this, I'm going to do something different, which is if it's going to be similar, but not. I want to have this off this side so I can see the declaration while I'm doing it. If clues I can drop, pursue. So just like this one up here, if it's more than 0, then we'll do something about it. This is much easier than the other one because we're using integers. So we can totally just go that. It will give us the right thing. So we grab that. But instead of droppable evidence, it's just clues I can drop. And then we've got what we want to drop. One small thing. If oh wait, it's not just, oh no, That's gonna drop. All right, I'll take it. If clues I can drop. Oh. Dot. Sorry, not that. So we've got integers here, right? But we need to look at the value of this. So somewhere I have to set the clues up as something I can access here. And that's going to be our kind of like a big one, I think. So for now, I think I'm going to hold that down for a bit. What I'm going to do is that's eventually I'm just going to go, okay, I can make it static. I'm not risking it. I'm sure there's some terrible thing that'll happen if I try that, but we're going to like kind of like make a pseudocode this up so you know what I'm getting at. This will be all right, I'm just gonna finish my thought, Del. And then so if it's unique, it comes out of things that we can drop. It exists in the world because it's in the master graph, but I can't drop it anymore, so we got to remove it. But because we don't have our master clue, a reference to our master clues here, I'm not going to bother implementing that until we do that. Then all we have to do is return clues I can drop. Because you don't want the actual like index in clues I can drop. You want the index of the index, the number that's in the clues I can drop. Oh. And if we can't, if there isn't any to drop, -1, you don't have any. Collecting a clue. Collecting a clue is gonna be fun. So this one has to check if we already have that. If I'm, give me a second. If I go I think we already have that. We have like it built in, right? Creating and filling. We can int and init, add in place, add unique. So we already have that built in. We don't have to actually like do it. So we can actually just go oops. that simplifies that a bit. I'm just gonna double check I've got remove index proper. Right? Remove elements I consider equal to the element. Remove single, remove at. Remove at, not remove index. I know I haven't, like, this isn't going to be turned on, but at some point we'll turn it on, and it'd be nice if it just kind of worked. Identifier knowledge. No lead. Shh, misspelled it somewhere. There we go. All right, so you can see this is actually a little bit more simple than we had it before, right? Before it was a little bit like, oh, what the hell's going on here? It's a little bit complicated to look at. However, now it's like, what? If we don't do unique items, which we don't have to do in the first run, it's a total of 1, 2, 3, 4, 5 lines, not counting curly braces, right? And then in our UI, that's where, yes, we are going to eventually have to do a thing where we like figure out how to get a reference to the main clues in here, or at least the UI. But yeah, that's pretty straightforward. All right. So that's the big question. I think I'm just going to double check. Oh, we forgot something over here, which is the moment we touch it. Oh, wait, sorry. The moment we touch it, we add it to our touched list. We touched it. Say we did it. Continue down the line. All right. I don't think we needed that extra thing, right? Because we stop when we find here. That gives us the ability to start on something and then look for the next one of those, which might not happen now that it's a one-way link, but who cares? It should be good algorithmically. Will it blend? Probably not. Let's find out. I expect me to have like something really dumb, like a bad declaration on like the player state, because I haven't done any of those. I've done like I did some pre-compiling on the clues to make sure that actually like the empty declarations were working, but I don't know about the other one. I think this will go much better than what we had before, because having everything isolated meant that you had to like, you couldn't verify and you couldn't score. If that makes any sense? Like we could do a thing where a clue is worth a certain amount based on how far away it is from a person. I don't think I will. I think right now we just gotta get it to the point where you can narrow it down to like one person. You can say, okay, this hair points at 2 people, this points at that, and you go down the line, and you can go down the line and say, oh, this guy shows up. This guy is eliminated. What'd I screw up? Am I crazy? Did I not just look at that? Interesting. T array. Is found not a T array? Did I mistype it? Found T array int found dot add. That is what it's complaining about, right? I'm not like so bad. Found add clues v. Clue star is a pointer. Clue star is a pointer. Interesting. All right, let's go look at what we've done. Clues. Is it a pointer? Shouldn't be a pointer. Am I off my rocker? All my rocks, they're off. Okay, I don't think I need this. I think we just exist in this world. There it is. It's not that. Okay. So we go clues v equals tag. We don't add the clues. We add, we just add v, right? We're just, that's the thing that we're added. So that should fix that. And then it's append not, I thought it was append, but I might be wrong. Add and place, insert, add new, set num, insert, append, add unique, oh, you need to say how many are in there. And side, oh, from another T array. Or, okay, all right, never mind. All right, so this returns a T array, so this should work. Let's make sure we got the dumb thing fixed. Great job, everyone. It's complaining about. Oh wait, this dot. We decided we don't need the this. Right? Does not return a value. Good job, Del. No, that works. Right? You go through the whole thing. You should go through the whole thing. Oh, no, wait. 107, guest player state. Oh, yeah. Does add unique tell me if it was added uniquely or not? Let's take a look. Do I have a link to like hardcore documentation for this? I guess at the bottom. No, that would be too much like a Microsoft thing. All right, give me a second. Give me a second. Because we've got that link, and then we have. Maybe I can do. I knew if you do it right, you could get it. It's references, core, if it doesn't exist, index of item, parameters. So it doesn't tell you. It doesn't come back at you. All right. Well, it's my function. I can call it all I want. Do we remember if like it uses the spool? Let's find out. Remember, we use this in the clue. We do not use it. So who cares? We're okay to leave that out. Compile. It's taking a while. Maybe I made it. Maybe it's just teasing me. Oh, nice. Okay. Doesn't, so it compiles. That means something, right? All right. I've got that there. So we have new clues. We need to figure out how to create something that like exists for everything, much in the same way the like when we look at ability system components, like that appears out of nowhere, right? And we can use it. We'll need to do that for our clues. We use that in here. We looked at it just now. And that comes from ability system globals. Should we go look at it? Does it exist? Can I look at it? I can look at it. I can look at it. For a declared class. All right. There's our object. That's a lot. Maybe it's something we should look up instead of looking a bunch of C++ code. All right. I have a feeling it's not as complicated as I think. Ooh, 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 ooh. Does that mean, hold on. Uh-oh, I'm in too deep. There we go. Oh, I'm still in too deep. There we go. Interactive gameplay, state, alcohol, because we have that, but it's blueprints only, isn't it? If we go in here, we've got game instance. Wait. Could we just? Oh, but it's a blueprint, right? You couldn't do that within the C++. You wouldn't be able to refer to this one, right? Like I couldn't do clues. Type will be clues. No, it's not. It's not even there. Do they not show up here? No? Okay. Structure clue, BP base clue. Oh, interesting. All right. Oh, wait. I think I need this. This also has a generated body. Right? Is it in the public part? I think so. I'll put it here and see if it complains. Where does it put it in here? Above that. All right. If you don't put a generated body in there, it won't like become Unreal Engine completely. So let's do that and see if that does what I want it to. It's taking a while. No, that's Okay. It's skipping this. Blues. Oh, something. Wait. We're missing. It's not an Unreal class. And it's not actor. It's just you. Whoops. It's just a U because it's not an actor. There we go. That's the funny thing, because you can have normal C++ in here. You get these weird situations where you write things that don't appear in Unreal because you've not that one. Yes. I care about that. Yes. All right. Yeah, so you can have like, you just compile as normal C++ that just acts like normal C++ and doesn't show up in an Unreal editor, or you can, it will still work in like the rest of Unreal in this C++ code because it's C++, but will not become Unreal stuff until you do that. And I'll bet I've broken it forever. Or not, who knows? Still doesn't like it. Did I save this? I did. What do I have to actually that's not the kind of class I was thinking of. Thank you. Do I have to inherit from like a base class? Is the question. Public parent name. But it's saying it's skipping it, and I don't know why. Do I have to? Does it have to be UObject? Like I think I have to like do something like that, right? Because if you go into here and you say I want to make a new C++ class, there's like you have to inherit one of theirs. So if we look, all classes, right? So it has to be like this. I pushed save with UObject. So in theory, if I'm right, then this will go. If I'm not right, this will not go. All right, what I'm gonna do, this is what I'm gonna do. No one's gonna expect this. You following? You following? We will make sure. He'll do it that way. No, I know why it failed, because it doesn't have any code in it. All right, so now we have, what does it think it looks like? All right. I don't know what this, but I hope it means okay. And then that. That. No, right. That's art. I guess we would just copy everything, paste everything. Save that, right? Because all we've done is made sure that the type declaration on clues looks like what it expects. Public, it's probably what it is. I don't think so. Just complaining about fart. Good. All right. Just complaining about fart. We don't need to keep these. I don't even know how we compile. We're trying to make a global, and then people are like, put it in your game instance, but we don't see it in the game instance. A happy compile complete, yay! Because it wasn't in there. So if I go game instance JJJ, still not there. The F clue is there. what we need to do is pull that out, make sure that's not the problem. So if we go, so we don't actually have, there's no thing in there for adding a struct, I don't think. We have most of the struct anyway, so who cares? Grab this. Grab most of that. Dump it in here. It's gonna be clues, it's gonna be clue. Clues. Once I get rid of this, does it care about the gameplay tag container? Yes, gameplay tag exists in here, so yes, it cares. All right, so clue.h. Don't think I need this. I'm going to follow what this does, which is just to have the what you need. Clue.h, clue.generated .h. Run it through the ringer again. That might be it. I just have to pull that struct out of there. Oh, that's not gonna work. Because I need to otherwise it doesn't really like work. Shouldn't work. It's trying, but it's not going to work because I won't know what it is, right? Right? Yeah. All right. Again. Try against computer. Nice. All right, let's go back into here. Hot reload. No, I'm gonna do clues. Still no clues. Hot reload clue 0. Hold on. Close this. Reopen it. No, it's still that. All right, give me a second. Let's see if I can do it now. Nope. I think I have to reload it. No, that's unique. I haven't done that in a while. So U clues, F clue, U clues. This compiles. It exists. Just have to like figure out why it doesn't show up anywhere. Evidence. Evidence shows up places. This class shows up places. inherits player state. Does that have anything about being? Oh, no. I want no class. For declared here. For declaration, right? These are all forward declarations. There's no like, this is actually like the declaration. I don't think I get that one. No, I must be doing something different. What am I missing? What am I missing, folks? Attribute set. I'll bet I need to make a blueprintable. Let's do it. Oh. I hope I don't have to actually, you know, it didn't take too long to reopen, did it? Because if we can pop it onto there and then we can use it somewhere else. And if this, we don't even need to do mostly, right? Because we can do parent class as advanced friends games instance. I can inherit that one and then add my little bit and then reparent that to this, reparent this to that, and get that. There it is, clues. What can we do on it? Do you remember? Get? We have get? I forget. We have get. We have find. What can we do on glues? Should be able to do stuff. No, because we didn't add them to the list of stuff that we can do in blueprints, right? Because they should be blueprint functions, which you can do on something like a guest player state, right? You function blueprint callable, which is something that these should be able to do that for all of these, right? So this is turned into fix my stupid, but that's okay. I have lots of stupid to fix. I'm not gonna bother until I actually remember. We don't actually have like a use case for this one. It just exists because I thought it was a good idea at the time. This is your lesson in like keeping your work from getting away from you. Don't go down the rabbit hole of maybe I'll need this, because then I have to write it. Don't even expose it to the rest of the application if you don't need to use it. You know what I mean? It'll work. I believe in you. I believe in me. My ability to copy paste like a small declaration. Meta tag. Whatever you want to call it. I forget what they're called. I did a lot of C#. We used them a lot of the time. All right, let's see. Can I? Oh, it's ready. I know it's ready. Show it to me. Glues, hot reloaded glues. That's fine. Get glues. We can find. Wait. If it was the one that isn't reloaded, then I just need to like close and open it. What if I just need it? You turn it into a boolean and then turn it back into a clues. Oh wait, that was the one that I didn't implement. Get. There we go. Yeah, there you go. And my index, and then yeah. So we can get things. We can. What else can we do? We can walk to. Right. Don't know why that comes out there, but whatever. Oh, because it's a pointer, so as far as it's concerned, it comes out. Yeah, makes sense. Makes sense. And then what was the last one we have? We have add. And then over here it's a structure, so I'll make a clue. And there you go. Not even that. Not even that. All the way. Nope. Clues, facts, care. So you'd make that. That would be the entire. That would be the entire thing. And it would be common by default, I think. Not common by default. Yeah. So that has how you populate it. All right, that is working. Good. Delete everything. Close it. How can I tell it to not save? Anyway, so there's that. All right, so those are there. They're there. They work. They're there. What can we do next? We can get. So let's just give me a second. Let me think about this. Let me close all the windows. That's not the button to close all the windows. Let me close all the windows. Oh shit! I've lost the plot, guys. There we are. That comes source. All right. Got this. We want to be able to reference that in here. I've got too many windows open. So I'm going to close most of them. I've got that in here. So in the player state, can I let's see, functions. Overridden from UObject. Is that a thing we can do? Left time replicate, I don't know. Actor, destroyed, human readable name, reset. Public, unique ID, client controller, dispatch properties, dispatch, duplicate, get compressed ping, get old player name, get owner player controller, pawn, controller ID, score, bot, is it bot? Lots of bools. It says void, I don't really care. Seamless travel, oh, that's a void. It just tricked me with having a nice link in there. Void, 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 void. You can set the unique ID, void. Oh, where is it protect? Oh, maybe it's just a variable. Custom name, engine messages, exact ping, on pawn set, session name. Is it protected? Copy properties, override with inheritance hierarchy comes from A actor, A info, A player space. Essentially what I'm trying to do, if I can get the game, either the world or the game instance, I should be able to, right, we've got a game state, right? Sorry, we have a game state where it exists. What does this inherit? Game state based. Can we get the game state from the player state? Player state, I think we can, right? Because we already kind of did this with, we've got the character. Get player state. Ability component attributes. Well, okay, no, that went the other way. We've got a state. Character. I swear we've done this before. But we can get something like that. It can't be that hard a question. Game someone must have done it, right? I can't be the first. Middle click. Game mode, game state. Accessing game state from client. We got a few ways to go about this. Ignoring this one for now. We know that. So they're putting on a game state, because that makes sense to me, where this game has clues, right? Okay, this is my hot take. My hot take. Game state. This is the game state? Is it my game state? Mystery game state. Yeah, okay. We can do this. Okay. This can do the work of being like for all the clues. And then we can access everything for now through blueprints. Because this is a blueprint. Yeah, I know, you just didn't show it to me. Because this is a blueprint. So it doesn't have anything in it. We could totally make this, right? There's events, and then there's, oh, there is stuff in here where we can give dinner and set everybody up. So this would be a good place to put that too. Great. Yeah. All right. The only thing we need the clues in for to be in C++ for now is the edge case where, not in here. The edge case of if it's unique. And if we're going to make it unique, I would argue that maybe we could do it on the outside. So like when you go on the outside, then you can, in blueprints, you check to see if it's unique and then remove it from the clues there. Or clues to drop there. Not the clues overall, but clues to drop. Clues I can drop. And it's a public, look at this, it's a public. I think it's public. Give me a second. Right? I use it somewhere. Right? I use it here. Get evidence to drop. Also do, whoop. And then I can, array of integers. I can remove it here. Right? So we could do get a clue, look at the clue in you could do this, then this, clues. Get. I have to go all the way up here to call function. We'd get our get clue to the drop. And we would check it in here. And sorry, not remove index. It would be get clue to drop. Remove item. And then we go, all right, this, and it's going to be one of these, and then it's going to be one of these. Come on, guys. Get. And it's going to be, can I split this here? Split. Unique. If. See how this ends up going like this, and then that's the value. This. So we can do the drop. We can remove the unique item out here for now when we come to it, which we haven't done yet. So that's great. All right, we're on our way. So what's next for us? We need to go into our detective system stuff. And so these clues need to be based on our C++ clue system now. So how does that work? Let's look. Break evidence, make evidence. Get tag name, append, string. Handle notice. It's not in here. Notice should be in here. Oh, because it's noticeable actor. So we've got the noticeable actor, gets object name set. All right. Yeah. Notice range, handle notice, required tag, unique ID, acting player, look precision float. All right. So we've got the whole line trace. Essentially, are we looking to it? Blah, blah, blah. Handle and notice. All right, we've got that. What makes it a clue? And what makes this test clue work? This is for both of us. So we make an evidence of kind of fact, and we set this evidence to that. Base clue, when it gets noticed, it uses an evidence. Guess player state is noticer, collect it and add it into evidence. So our base clue. So what we can do, we can, the kind of weird thing we can do, because I haven't deleted the evidence stuff, is we can actually do both at once. So we can say that a clue exists, a player state. No. Thank you. Sequence. And the first one is we're going to go and do that one. Let's make a little bit of room here. Right? That's our original one. The second one is that we can actually go down here and guest player state collect clue, right? So we can do both because we haven't deleted the evidence system yet, right? There's your clue. That goes in there. And I found a clue. And I changed this to, I found evidence. I found an evidence. Evidence. And then that. And for this one, we'll do the same, only it will say clue. And then this is our kind of like poster child for how do we show the clue, get at the clue. So we want to can we get game state from here? We can cast it to BP Mr. Game State. We can clues get. Should call that something else just to like make it easier on myself. And it's gonna go all the way, all the way to here. All right. I don't want to drag that line across, but that line is this line, so yay! Clue. And then we're gonna split this. It's a string append. We're gonna say I found a clue. Once I remember what the caps lock button is. Don't care, I'll use shift. That's not shift. Space. We can go tag, we'll do the conversion. And print, or make this text color different. Maybe we should just make it like dark green. We've got this weird system where we can do both things at once, two things at the same time. This is going to be a little bit harder because we're going to have to know what this clue is, which is why, not tonight, we'll do it later. We'll set up creating all those basic things. Like I said, I'm kind of tempted to just put all the tags in here and then giver, because that's the only thing that makes sense to me. And then we can make a whole bunch of crazy stuff like, oh, I didn't know that was there. We can do a whole bunch of crazy stuff like an enum, and then in C++ we can refer to them by their tag name. I think that's what you're setting up here. We'll see. But yeah, I think that's good. It compiles. We got all our things come out. We haven't tried to walk yet. We can do that later. But I think we did a good job today for like a major system refactor and or replacement. More of a replacement because we've got the two systems working at once. But I think the new system is going to be better since it's not going to like stick us with like copying entire clues around. Is this the same clue as that one? We have to compare that. It's like, no, it's just give them the ID, give them the index and the array, and it should be good. All right. I think it's time to go. We'll see you next time.